for you. So the agenda we have here is we'll start with the technical server market update. Also taking a little bit, you've seen our traditional numbers show a little bit more about the market beyond the servers, looking at storage and the other aspects of the market and our forecasts. Then the studies I mentioned is we did a very large study for the Department of Energy on HPC talent skill sets. Basically we have an aging population. We don't have a lot of young people coming into the field. So where is the best place to find talent and to address that overall situation? And then the second one we'll cover is improved ways for scaling technical applications in Europe. So this is a study that we did last year. And it's really around, if you look at all the technical applications, so think of 5,000, 10,000 separate applications, how do you move that whole bulk of applications forward? And then the third one is some recent things that Steve's been doing in the big data area. As everyone knows, that's one of the hotter topics these days, and we'll walk through how IDC is trying to get organized to really address it from all the different functional areas. And then we're going to wrap up with the new HPC Innovation Award winners. You're familiar with the team here, and Lloyd's in the corner there. So if you haven't signed in, make sure you sign in with Lloyd or leave your business card because you'll get a copy of all the slides. We'll send that out to everyone. Some of the standard activities for those of you who don't know IDC in detail, we do attempt to track all HPC servers sold around the world every quarter. And when we do the tracking, we do it from two sides. One is what ships out of the vendors' factories, and then we spend a lot of time with end users of where they actually purchased it. And we have a set of rules that we've followed for the last 30 years, and it's basically we don't put a machine in our database till the users say that they accept the machine. So quite often a vendor may ship it for 2 years, in parts and build it up, but until the user says I've accepted the machine, then it goes into our data structure. So for example, a very large one for us right now is the Recon system. Fujitsu has already shipped the Recon system, has for quite a while, and as soon as Recon says we accept it, then you see that entire amount of money hit the data structure. We also hold a number of user forum meetings a year. Steve will do an update on how that's going and the reports that we published and the various other things here. Our business has changed quite a bit in the last few years. We're doing a lot more custom studies. So if you have questions on various topics, feel free to contact us because when we do the custom studies, most of them we're allowed to share data with the community. So we can do that. But here's an example of some of them. Doing a tremendous amount of research on small, medium business and smaller users of HPC. All kinds of things around individual sectors, whether it's automotive, oil, gas, the intelligence community, homeland security type studies. A lot of work around competitiveness for the different nations of the world. And as you can imagine, power and cooling, of course, a lot of technical topics around GPUs, the use of SSDs and flash memory. So with that, I'm going to leap right into the numbers. So first of all, we continue to see very strong growth. In 2011, it continued at 8.4%. For the first quarter this year, and we just recently did a press release. Steve, did it go out this morning, I think? Or Friday? Friday. Okay, on Friday. So for the first quarter, it shows that quarter over quarter, we saw another 3% growth in first Q4. So the growth rate is continuing to be very healthy. We are forecasting a roughly 7% growth per year for the next 5 years. To put that in perspective, if you look at commercial servers, right now commercial servers are expected to be relatively flat, or they may even shrink a little bit over the next 5 years, primarily due to virtualization. But there's still just tremendous challenges in using the systems. We'll walk through each of those in more detail. And then the last one, which is what we're spending just a lion's share of our time, is to figure out the whole petascale, exascale race. As I think most of you are aware, what we changed a few years ago is whenever there's a new giant system installed somewhere, we actually fly out there and do a very extensive survey to try to understand what's going on, how it's being done. One paper we're just finishing up now, for example, is when Fujitsu did the Recon system, they did it ahead of schedule. Most of the giant machines throughout the time have never been delivered ahead of schedule. There's always delays, problems, and issues. So we've recently just finished up a write-up of the Fujitsu factory. Went to Fujitsu, looked at the factory, tried to learn how they were actually able to produce that machine ahead of schedule. And it's just fascinating because Fujitsu did an excellent job on that. So here's how the market looks as far as the different segments. Supercomputers are 1 million and above, and these are our traditional categories we have here. And you can see that there's a very big change in the market dynamic. Even though the market's growing overall, the lower half of the market is not growing. In other words, if you look at medium-sized systems and small ones, since the 2008 recession, that part of the market's stagnant and is not expanding. But if you look at the high end of the market, for machines 1 million and above, it's reaching almost half the entire market. And it's showing very extensive growth. And we're trying to understand really this new dynamic. Is it something that just happened because we had a recession? The small part of the market hasn't quite recovered and it's going to go back to its natural or the historic format? Or has the market really changed? And we're trying to come up with actually some kind of new terminology. You used to always talk about the pyramid. You had the few supercomputers, more in the middle and at the bottom. We think now that's more something like a diamond on top of the pyramid, where you have these mega machines sitting up here that really are just massively different. And when I say massively different, it's here I'm mostly talking about price tag. $100 million. The Recon system, we're still working with what the exact dollar value, but it's on the order of 500 million, plus or minus 100 million. So we're working through that to figure out the exact numbers. Now here's a picture looking at the same segments as far as the number of systems actually sold. And again, if you look at the market change here, we're at almost 3,000 supercomputers of 1 million above being sold a year. So the industry in the world is really changing that way. And again, the lower end of the market was where you see the pressure. Just for those of you who haven't seen our data structures, we take it down to 13 sub-price categories. So if you ever have questions about what's going on in these different bands, and we can map these data structures against things like regions, processor type, system architectures, just a host of different parameters. And I'm just doing some snapshots here. So this is by region and what's going on. You can see that North America basically is somewhat flat. Not a whole lot of growth there as far as what's going on in the US. And if you look at Asia Pacific, there you're seeing just tremendous growth. Now, the concern about this shift in the market to these giant machines, when I mentioned the Recon machine being on the order of $500 million, look at the size of the Japan market historically. You're talking about one machine that's almost as much as the country purchased in a year. So you're going to see fluctuations now in the numbers that are going to be hard to understand. And the one recommendation we make is be very careful about taking 2 years or 3 years of data and drawing a projection line. Because when you have big fluctuations, it's going to give you some pretty poor results if you try it that way. So here's by region, just showing more in a pie chart for 2011. Also wanted to drill down a little bit just what's going on in Europe, since we're here in Europe. Again, you can see the supercomputer segment has grown to be more than 40% of the market, and the lower end of the market, again, has shrunk to about 13%. Now, the one biggest concern that we have, and we're trying to figure out from an economic viewpoint, is this workgroup market could easily double because, it's been under so much pressure and it was under a strong growth rate before 2008. But at the same time, those workgroup or smaller purchasers may decide using the cloud's a better solution or using something from a data center. So we're trying to figure out after, kind of the recessionary and economic pressures relax, do they go back to buying systems or do they use alternative ways of procuring their cycles? Now here's another snapshot. This is looking from a processor viewpoint, and this is in cores. These are actually the processors that Intel, IBM, or AMD sells, so that you could call it sockets. And you can see the market right here is from a processor viewpoint, it's grown about 6.3%. The HPC market consumes roughly on the order of 3 million processors a year at this point in time. And again, when you look at some of the trends for these mega systems, one mega system could be 1/3 of that. So you could talk about some very big changes. As far as the different vendors, this is showing the 2010-11 as far as the actual numbers and the percents. You can see that HP and IBM basically from our statistics are in a tied position. We always show our numbers to a decimal point. The reason for that is for the smaller vendors we have very good accuracy for that. For the larger vendors, our accuracy at best is 1.5% as far as market share. So that's all within that realm. Then Dell has been doing fairly well. We think that from what we're hearing is the Dell numbers may be doing an uptick from that in this year because it looks like Dell's having some good successes in a number of cases. The Cray numbers are doing the fluctuation that I was referring to as far as, when NCSA gets accepted, you're going to see Cray just spike and so on. So you'll see Cray bouncing quite a bit. We're actually expecting that in the next few years, Cray may sell one system in a year somewhere that's more than in 2 years of revenue. So when I say some real unusual dynamics taking place there. You'll notice that we have an other category here for the other vendors. Vendors are allowed to have their numbers kept private. So in the other category, we actually track about 36 different vendors right now. And with that, I'm going to hand it off to Steve.
Sure, thanks, Earl. And by the way, if anybody wants the slides, they will be available. You can just leave us a card and write the word slides on it, or just email us, ejoseph@idc.com, sconway@idc.com. So let's look ahead at the numbers and what we see going up. 2011 was an exceptionally strong year for the HPC server market, as Earl was saying. We originally forecasted at 7.2% year-over-year growth, and it came in at 8.4, so a very, very strong year. And you can see on this chart the pattern where the recession hit, and that the server market in HPC has come nicely out of that recession and is kind of ramping up toward where we see it being in 2016 at about $14 billion. So if you look by competitive segment, you see some of the pattern that Earl was referring to there. What we think is going to happen in between now and 2016 is that bottom piece of the market, particularly the work group, that's systems that sell for under $100,000, is going to be coming back. What the recession did there, because those were discretionary spends, is that people delayed their purchases. That was the fear factor, and we think that's going to come back, so we'll see strong growth there. But overall, all segments of the market are going to see some pretty good growth, at least compared to the server market, the commercial one. Here's what it looks like by vertical, and what you see here is in 2016 there are going to be, we predict, 6 vertical segments of worth $1 billion or more each. 2 of them worth $2 billion or more each. The biggest growth will be by percentage in financial services, and people make kind of a big deal out of financial services market. It's an exciting market to talk about, but it's not a big one. Where these sectors go, that is not a really big market, but a nice growth rate. The big ones are going to continue to be academia, government labs, defense, and then CAE, manufacturing related, is coming on strong again. You see there are over 9% growth rate. So that was the HPC server part of the ecosystem. If you look at the broader market, what we see here is a pattern that we've been seeing for a couple of years, which is that the storage market has been the fastest growing piece of the whole puzzle. It's been growing at, some significantly faster than any other part of the market, and that's driven by the growth of data-intensive activities in HPC, so the need for storage capacity, management, and performance. And that will continue. So that storage market is going to wind up about a little over $5.5 billion at the end of this period, we believe. Earl mentioned before a study that we did on HPC talent. One of the reasons we did this, well, the real reason we did this is because the Department of Energy asked us to do it. But it also conforms to a pattern that we're seeing everywhere that we travel in the world, which is that people show us their 5-year plans for their centers or the departments of the government, for example, and then they say the big issue is finding enough of the right kinds of people. It's kind of a worldwide problem, and we had the opportunity to look into it because of this study that was sponsored by NNSA here. And in this study, we looked across the Department of Energy laboratories, but we looked at data centers not just in the U.S., but throughout the world, and also academic sites, 41 sites in total, and it was a very in-depth study, and I'm just going to go through the findings here quickly. The first one is it confirmed that there really is a big problem there. Almost all of the data centers said that they're having a hard time finding an adequate number of the right types of people. And this is not limited to government. It's all sectors, including industry and academia. One of the things that was interesting to see confirmed is why this was happening. And it's sort of an interesting complex. What happened in essence is that the U.S. government historically was the largest customer for HPC. After the Cold War ended, which was a good thing, the government really sharply and pretty quickly reduced the funding for HPC. And those of us who were around at that time in the early 90s remember coming to the supercomputing conference and so forth, and it was a pretty grim kind of a conference in those days. The numbers were not good of attendees compared to prior years and so forth, and vendors were kind of winking out one by one in the industry. The media who covered the industry kind of were dwindling down to just one or two. So that was a very, very, very tough period. And what happened was also because of this contraction of funding for HPC, programs at universities in computational and science, the number of those programs within just a few years kind of plummeted. They haven't recovered from that too much yet, even. But what also happened is at the same time, HPC kind of got branded during that period as an old technology, kind of a Rust Belt market that was going away. At the same time that the dot-com internet market was growing, so young people who at that time might 10 years before have gone into HPC went the other way. They went with the new technology and away from the old technology, which was HPC. The HPC market has recovered nicely since that time, but the perception is still hurting us for getting the right number of people through universities. So what the study showed is that the categories that are most in demand and most in short supply are parallel programmers, algorithm developers, and sysadmins with a lot of experience. And particularly people who have the combination of talents, who are proficient in a scientific discipline and in computational science. So what the data centers said was that they can't find enough of the right kinds of people, but it hasn't affected the quality of the people they do have. They still have high quality people, just not enough of them. So we asked, well, what are the best ways of getting candidates? And it's, as you might expect, universities, #1 source for candidates. And then stealing people from other data centers is a #2 source, because it's kind of a zero-sum game. Somebody gains an employee, somebody loses an employee. That's a pretty interesting pattern. And then, of course, the web is used more and more. This was a little bit of a strange one. We asked, well, what about trying to transfer people from general IT data centers or commercial enterprise data centers into HPC? Very different environments. And what we heard was, well, there aren't too many people as we interview people from those domains who we think who could make that transition. Not a whole lot of them, but on the other hand, 4 out of 5 times when those kinds of people were hired, it worked out well. But it could take 6 to 12 months, even 2 years for them to make that transition. It was a culture shock that people went through. And this won't be a surprise to anybody in the room. The biggest challenge everybody faces, according to this study, was, again, parallel programming. The biggest challenge. And we kind of got the underground, kind of a welling up of consensus where people said, we're just putting it off the inevitable. Many of these codes will have to be rewritten from scratch at some point, but nobody wants to know exactly where that point is. And the issues are interrelated. You can't separate them. It's not just parallelism, it's heterogeneity, it's power and cooling, it's balance, and so forth. And any one of these could be something that stops progress. And one of the other things people said is that what would really help is if the market for HPC could be larger in size. Well, it's gotten larger in size, but the people in this study meant really larger in size than it is today. And that could make the academic path more attractive for people and the career path more attractive for a greater number of people. But people are very concerned about the types of systems that are predominant in the market today, and including even at the very high end, and saying, like, one of the things that's worrisome is that it seems that every next generation of supercomputers, particularly at the high end, have a narrower breadth of applicability, that they're applicable in practice to a narrower range of problem types. And not surprisingly, people said that, you know, what's the remedy immediately? And it's to get working with the universities and for government to step in and really help that process along. One of the things that came up that people were very puzzled by, or more people than we would have expected from a survey of this type, is that they said, we don't get it. There's some kind of cognitive dissonance here because, you know, if HPC is supposed to be the third branch of the scientific method, which people have been talking about for 20 years, how can it be that in so many academic, even PhD programs, it's not an integral requirement for anybody in the basic sciences? It's still an elective. That doesn't make any sense. So some work needs to happen, people felt, with the universities. And with that, Earl,
okay,
we'll talk about the software study.
Great, thanks, Steve. So as most of you know, a couple years ago we did a study for the EU on behalf of the EU as far as how the EU and Europe could have HPC leadership by 2020. We had a set of recommendations, and we're extremely pleased that Europe has found the funding for major parts of the recommendations we made. But one of the key areas was that addressing the whole software issue. So the EU asked us to do a second study, and as I mentioned earlier, what this study is, if you look at all the software across Europe, so the study first started with, you know, doing a survey of where all the software packages are. How do you move them into a more parallel world? So that doesn't mean trying to get them 100,000 way. It's looking at some software that may only be 1 way, 8 way, and how do you move that to the next level? So for each piece of software, how do you move that forward to make it take more advantage and make it more productive? So what we did is we first mapped the entire parallel code landscape in Europe. So that was the major starting part of it. And then we created a set of recommendations. And in today's talk, I'm going to just give you some snapshots of what we found as far as raw data. I'll show you where you can download the whole report. But I'm going to spend my time mostly on what the recommendations we have. The EU is looking at implementing these then for the 2013 framework. So the funding on this one hasn't been in place yet, and they're just working through the nature of how to actually implement the whole thing. The information sources, as I mentioned, we did broad end-user surveys. We talked to a lot of folks in Europe on this one. A lot of in-depth interviews with key officials, too, because we wanted to find out what would work, what wouldn't work. Of course, a lot of software is from ISVs, so we had to talk to a lot of ISVs when we were developing the recommendations. You know, are you willing to make this change or this change? You know, how is it going to impact your business model? So we tried to come up with a set of recommendations that actually works for the whole community as a whole and doesn't try to force any unnatural behavior, so to speak. So some of the key findings is, you know, Europe has a number of globally successful scientific and engineering software firms. Europe has been very strong on the software algorithm development, a lot of the debugging tools. I mean, there's just tremendous kind of natural knowledge base across all of Europe. When we looked at all the software packages, though, if you take a look at the 5,000 or 10,000 pieces of software as far as applications, a lot of them are used by one professor, one department, maybe 6 people. You know, so a lot of the codes we're talking about here are in a small business, perhaps, where there's 5 engineers that use the code, and it was written 20 years ago. And the person who wrote it isn't around at all, but the people who are using it, they kind of know how to use it and adapt it, but they don't know how to rewrite it and restructure it. But the underlying problem right now is that modern HPC hardware doesn't match to old-fashioned HPC software. The old software that's in existence just doesn't map to many-core environment, small bandwidth to cores, and, you know, cores are basically free in the system. So there's just an entire mix match. And you've heard us say over and over again for the last 5 years, you know, at some point in time, almost all software has to be rewritten. You know, and so when does that point in time happen? So the next thing I'm going to do is just walk through some samples of the data just so you know what's in there. So, you know, this walks through some of the origins of the codes, the creators' countries, where the codes came from. Here are the IP owners. We got into a lot of issues. For example, if you're going to rewrite software, you have to know who owns the software, who has the right to change it, and then own whatever happened afterwards. A large surprise to us is the bulk of the code running on HPC systems in Europe were written in Europe. And so that was a big surprise for us. So most of the IP is actually owned at a very localized level, which makes the problem much easier to solve. The other whole structure that we're looking at is, what's the willingness to improve these codes? You know, if you have all these codes out there and most people say, hey, I'm happy with how it works, I'm just going to get a faster workstation, then it means moving forward makes no sense. And of course, what we found is almost everyone was willing to change it And this is entirely different than when we did these types of studies 5 years ago. In general, only half people said they were even willing to look at their codes. And also, as far as willingness to partner with almost anyone, willingness to work with the EU was also a surprise too. The general view is having the EU do a structure that covers all the countries was a very positive view by most Europeans. The programming environments used, sorry, this is somewhat of an eye test, but no surprise to most people. So this is looking at each of the software packages and that, so some packages use multiple things. Hey, Fortran's 75%, 80% of that list. I mean, it is still a Fortran world. There is a fair amount of C, some C++, but then after you get beyond that, this is just an entire mix of programming environments. Also, what is needed the most, and is no surprise, and from what Steve was talking before, is the lack of talent and the internal staff and experts and having the actual ability to do this. In most cases, the sites we interviewed outside of large centers did not have anyone in-house that could actually rewrite their codes. So the bulk of these codes, they just don't have the folks that can rewrite it and take it through a change. And of course, some kind of money investment. Now, when you see us say the investment one, that means a return on investment. If you have a code and you think it's going to take you $1 million to make it better, are you going to ever get a return for putting that $1 million in? So it's much more an understanding of the value of making the change. So with that quick overview, and like I said, I'll give you a pointer, and there's a lot more data that you can download from that. The first thing we said is, our recommendation was to use HPC parallel software development to help close Europeans' innovation gap. Europe, much like the US, has a very big issue in that there's other parts of the world in Asia that is developing a lot more scientists, a lot more engineers, a lot more programming experts. So how does Europe keep up with that? And there's somewhat of a limited window of opportunity here, because if most software has to be rewritten and redesigned over the next few years, you're either part of that whole program or you get left behind. And here's an example as far as some senior people within the EU Commission and that, as far as their viewpoint. And if you look at the back one right here, is their big concern is the EU innovation scoreboard tells a similar story. There's a tremendous innovation gap that is developed between European standing relative to the rest of the world. And as we're pushing here is from our previous recommendations, we recommend that the goal is not to have HPC leadership. In other words, don't make these massive investments to own the HPC market, because that's a relatively small market and not that important. It's about all the science and engineering that you're doing with the HPC. HPC is a tool to get you somewhere, and it's about where you're getting to that's important. And it'll be determined, in our view right now, far more by advances in software than hardware. Now, future exascale hardware is hard, don't get us wrong. But the changes in software required are dramatically harder and can have a dramatically higher return on investment for that. And historically, we've always focused too much on the hardware because hardware is hard, it's something you can get your hands on, and you need the hardware before you can run the software. So we tend to overly focus on that. So the first recommendation we have is to create a new EC body to coordinate a more holistic approach to bringing all the software forward across Europe. Right now, if you look at certain places, like in Scotland, has a really great procedures they use for Scotland, but nobody else follows the same thing. And right now, most of the software is not being moved forward. And this is one thing that they're looking at putting in the body. They're having a number of workshops. We mentioned having the 2-day meetings. They had one of them just last week, but they're doing a set of workshop meetings to really figure out what makes the most sense. The second one is to take the existing centers of excellence, and it may require a couple new ones also, but the bulk of this is in the existing centers of excellence, for the EU to give some funding to the centers so they can hire some people and create departments, but basically have the centers the experts in bringing certain types of parallel software forward. So one could be automotive or aerospace, it could be CFD, and various ones. And so if you think of all the major centers across Europe, you want to create kind of a table that says this center is the top in these 3 apps, this is the top in these 5, these 6. And some of them may be the top in what, whether it might be in 12 centers or whatever. But you do this mapping of which centers are the expertise, and then Europe should fund to make their expertise much higher in that. In other words, start from a starting point where you're already strong, put some more resources, and become really strong in the world for the centers. The third recommendation, which in the next 2, the third and fourth ones, are really something different, though, that we propose. Think of this as an eBay for parallel software. In other words, it's a clearinghouse. It would be a web interface that the EU would put together. The first thing that this thing would do is it would have to do a massive amount of documentation of all the software in Europe. In other words, and when I say documentation, it's about what does the software do, where is it good, who owns it, how do I get a copy of it. So you're talking about 5,000 or 10,000 codes. So a fair amount of documentation to just find out where all the codes are in Europe so you can start sharing. You really can't share if you don't know what you have to share. So that's the first step. The second one is to create a storefront for the existing new parallel software, whether it's an algorithm or a complete code. So if you're a professor in the Ukraine or in Turkey and you have this great little algorithm, you can put it on this like an eBay and let people say, you know, if it's $2, $5, $1,000, whatever the price is. And again, we're not trying to change the market, but we're just creating a marketplace here for that. We'd also have it so that it would interface to all ISV software. And when we say negotiate here contracts, this is not having the ISVs change what they do, but to ensure that they never charge more if you go through this interface. And in general, if you go in the interface, if you want to get ANSYS or Nastran, it would just bounce you to their website and it would be, go through their normal purchasing models. But it would be a singular interface for anyone to come in to get all software they needed. It also would have various pay-as-you-go models where it makes sense as far as cloud implementations. It would also be a place where you could come to get service and training. And so there'd be a fair amount of training involved in this interface too. And what we're recommending is the EU makes the investment to create this to get it started, to get the information there, because if you only get through the first step or two, it's already a home run relative to the overall recommendation. In other words, knowing where all the software is and what it's good for and who to call if you want to get a copy of it. And the last one we added in is, hey, venture capitalists could use this to come in and make investments and decide, hey, I'm going to buy these 4 packages, put something new together. So this is kind of a marketplace, but also the information exchange. The next one, though, is so how do you really address this? And this is related to both small and medium businesses, plus all these separate concerns. And again, if you think of 5,000 to 10,000 different places, we did a lot of other side surveys on this, and the only solution we found is somebody has to physically go to each site and sit down and work with the person. This is not a case where you can do a great ad, you give away a PC, and people are going to come contact you. You actually have to go out there and physically sit down with them. Part of that, though, is they won't even let you come and sit down with them unless you're going to give them something. And what we're recommending is that Europe makes the investment, again, to help all the countries together by giving every organization that has parallel software 3 to 5 days of free technical support. And what would happen here is you'd have a team, a domain expert and a parallel programming expert. So that's the 2-person Tiger team. And they go visit the site and look at most of the software, the key software they're running. If there's some obvious changes they can make, you know, and we call those the easy improvements, they would make those right on site. And what we found when we did the surveys, a lot of these sites, they don't even know how to configure their ISV software. When I say easy changes here, I'm not talking about rewriting codes. I'm saying, no, you should be using the latest version of ANSYS and you should, you know, be configuring it this way. But the main thing that this team is doing, they're the interface or the selling arm for these centers of excellence. And what they basically do is they do the assessment, okay, here's the codes you have. We think this one code makes sense to go forward. These 2 codes, just leave them the way they are. You only use them once a year anyways. So they make that whole assessment. And then they get on the phone call and they get them connected with the centers of excellence. And the centers of excellence is really where all the expertise is. And the high bandwidth communications then takes place with the centers. So a key part about this is, as I said earlier, is this is the selling arm to get the centers of excellence expertise into the right organization and where it's required. And then also, you know, we were asked to put together, you know, the funding requirement for this. As we mentioned before, or the previous recommendations, about 150 million euros a year are required. Here's the profile that we're suggesting is where the funding is placed on the software investment side of it. So the investments in parallel software development is split between the member states, EU, and that. We are suggesting that the EU take the lion's share of doing the clearinghouse, so this is the website piece, and also the Tiger teams. We're saying these are the 2 pieces that we feel the EU should just take on, make those investments. Once they happen for 2 or 3 years, this is something that can be self-sustaining, and eventually the EU doesn't have to fund quite all of it. It may never ever become a totally profitable concern, but at least, you know, the government doesn't have to continue that funding forever. And in conclusion, as I mentioned earlier, good exascale hardware is absolutely required moving forward in large systems, but we think the main shortcoming right now that's just been a continual growing gap is on the software side. And it's in every area, whether it's application, middleware, compilers, I/O management. I mean, every part of the software stack, in our view right now, is very deficient. And we think that's where the largest advantages can be made. And here's the website. So if you go to the HPC user forum website and just do the /EU, You can download a copy of our previous recommendations to you and the study also. And we welcome any comments. You can click on there and send us comments. Tell us which parts you like, which parts you don't like, and ideas for changing that. And with that, I'm going to hand it back to Steve to tell you about what we're doing in big data.
Thanks, Earl.
There you go.
Most of the studies we do are private studies, well, vendors or other organizations, but the ones we're talking about today are public studies, and if you are interested in any of them, just go to that website of www.hpcuserforum.com, and you can download copies of any of those and other studies that we've done recently at no charge. So big data, it's kind of old story and a new story. Okay, so as we know, data-intensive computing is not new to HPC. It's been part of what we do since the beginnings of the industry in the post-World War II era for things like weather forecasting, government work, and over time, other kinds of things. So kind of what's new, we're seeing new domains emerge with some new methodologies applied, and we're closely tracking this in the kinds of ways that we usually do, both in a market sense, who's buying things for use for specifically data-intensive work, particularly the new methodologies. But we're also talking to users a lot, and for about the past 2 years in our HPC user forum meetings, sort of by popular demand, about I'd say 1/3 of the agenda or something like that at the meetings tend to be focused on users talking about what they're doing in this realm of big data. So major use cases that have emerged from those two things, looking at who's buying what and also hearing from the users, are these, and the top one is fraud, error, anomaly detection in lots of vertical segments and across domains. National security has been around for a while. The other big one is healthcare in a whole bunch of areas, but one in particular that I'll talk about in a minute. So the pattern that we're seeing here is, in HPC at least, is that people are applying established methods and also newer methods like Hadoop, graph analysis, relationship analysis, semantic analysis, and so forth, to typically the same problem, using the same HPC system. There are exceptions to that, but that's the pattern that we're seeing. And a great example, one that we think points to the future, is the climate knowledge discovery workshops that have been held at in conjunction with a number of major HPC conferences over the past couple of years, where you do see people wanting to apply new analytical methods to climate. They're kind of orthogonal to some of the simulation methods. In other words, you don't combine the results, but you get a very different perspective that can lead to the extraction of novel insights. So then, what we have to do as IDC is figure out, well, how do we define this thing? And since it's very much in motion, this is kind of a new phenomenon, big data, as it's emerging. What we typically do and are doing in this case is that we don't want to use a narrow prescriptive definition that's going to exclude some of what's going on there. We have a broader descriptive definition that tries, we want to cast a wider net and really see what's going on there. And so it's covering, we look at the established and the newer methods as part of one bucket, and mostly the people that we talk to in the HPC community do the same things. And that includes not just what you would think, but also there can be big accumulations of data from parametric modeling, stochastic modeling, and so forth that kind of qualifies as part of the big data scene that's emerging here. So, where's this data coming from? It's not just that we have bigger supercomputers who are producing lots more data. It's also that the sources of data to be ingested into these into these projects get to be more, you know, of sensor, telescope coming along and so forth. And a research model that now has taken over is also contributing data. On the side, as I said, iterative methods are bigger than they used to, and so forth. So fraud detection is the first moneymaker, that it's not just one customer paying for it, that we're seeing a pattern. You know, people are buying systems for this. And with fraud detection, it's error detection, it's anomaly detection. It's a pattern issue here. And here are some of the examples. I'm not going to go through them in any kind of detail here. We produced our first big data forecast for summarize. We have it in lots more detail by vertical and so forth. What you see in that second row there, big data volume, is going to increase pretty nicely in a forecast basis out to 2015 at over 10%. That could be very conservative. It's just too early to say. But third row there, what you see is that even in 2015 and 2016 estimation, any kind of major piece of the action in HPC, you know, mid 6% to about 7.3% in that sense. I also wanted to say that these numbers are already baked into the general forecast for HPC that we saw earlier. We look at this as a work view as we do other things. The way that we kind of work it is that we characterize a system in HPC according to the main purpose for which it's acquired. So what you're seeing here is revenue forecasts for systems acquired primarily to run data-intensive work. So what we see going forward is this is evolving very, very quickly. It's going to have to get a whole lot more dynamic, the execution models here for this. MapReduce, very big in the commercial sector. But MapReduce is a useful tool for HPC problems, but has real limitations also. We constantly hear that from the people we talk to. It's pretty cumbersome when you start getting to 100 terabytes, that kind of a data size and beyond. It really was not designed, as you know, to be able to, intelligent questions. You have to have these are very simple questions that you can ask with MapReduce, and that's a little bit orthogonal to some of the things that need to be done in HPC. As far as the hardware goes, we think most work, HPC big data work, is going to be done on clusters. Most times people are going to do this work on the same system that they would have bought anyway. It might be a little bit larger system. The storage part of it is going to be on average sometimes considerably larger, but it's the same system they would have bought before. But there are limits to that, and that's why we have things like IBM Watson. That's why we have things like the Eureka from Cray, which is really an appliance designed specifically for this market, because there are problems that are just too big and hairy to deal with in kind of a cluster or cluster-like architecture.
Steve, you might want to mention how IDC is trying to grapple with all the issues around big data organizationally.
Oh, yeah, sorry. Yeah, that's a good point. Within IDC itself, this thing is really proliferating. We have over 40 analysts who are now working on big data, and that's going to get to about 50 analysts in a month or so, and we work across companies. So we, who are covering under the HPC side, are working very, very closely with people on the commercial side. One of the things that we see happening, particularly in the last year or so, is that the boundaries are starting to blur between high-end commercial analytics and HPC. And you're seeing a lot of traffic moving in both directions across those boundaries. I wrote something for Suzanne Tracy's here for scientific computing on this recently. But some of the companies that really didn't touch HPC historically, like SAS, SAP, Oracle, LexisNexis, are kind of all over this. kind of pushing up because, and as we talk to them, they say, you know, well, yeah, sure, we want some business from HPC customers, but really what they're doing is they're seeing their commercial customers in a few years, and occasionally even now, needing to use HPC kinds of resources. In the other direction, it's not just the big guys like HP and IBM who are really gearing up for this and doing it pretty well, but companies like SGI, Cray, and others who are smaller are also kind of trying to arrow out into the commercial big data market. So, you know, where we kind of look at it is that business computing kind of split off primarily in the early 1960s from scientific technical computing as a branch, and they've kind of been separated since that time, and they may be, at least in this area, coming back together some. HPC User Forum has been around for more than 10 years now, and it is directed by a volunteer steering committee of users from government, academia, industry. There's the list. And IDC's role is that we kind of run it on behalf of the steering committee. Earl and I are on that steering committee, but we are non-voting members of the steering committee. But those are the folks who, at the moment, direct the activities of the HPC User Forum. And we have some meetings coming up. The meetings in international meetings operate in a little bit different way from the ones in the US. In July, we'll have meetings at Imperial College in London and also at HLRS in Stuttgart. And if you're interested in those meetings, again, you can look at the agendas and register at the HPC User Forum website. Registration's free. The attendance is free at the meetings. Our next U.S. meeting is in Dearborn, Michigan. That'll have a strong manufacturing focus in September. And with that, I'll ask Earl to talk about and announce the winners of our latest awards.
Great, thanks, Steve. So for those of you who aren't familiar with it, we created this program with the support of a number of sponsors. We appreciate the sponsors' help on this. And what we're doing is we're trying to collect a large set of HPC return on investment examples. Our objective is to get to 1,000 as soon as we can. We think that takes multiple years, and hopefully not 5 years, but hopefully something closer to 3 years. And here's the separate website. We invite everyone to apply, for an innovation award. I'll explain kind of the rules. The rules are real simple. The entire application form fits on one page, so we keep it simple that way. The main goals of the program is to show real ROI examples. When we've done our surveys for small, medium businesses, small, medium enterprises, and also medium-sized and large organizations, why aren't you applying HPC more today than you currently are? The number one example or issue that comes up is we don't really understand the value of it. We don't know the return on investment. We don't know what other people in our industry are doing. So we're trying to create this structure where you have a lot of examples, and somebody, if you're doing plastic deformation of this type of material, you can actually go to this data structure and find 5 examples of where companies have made a lot of money by using HPC for those problems. So we're creating this entire database structure. So all the users have to submit are 2 main parts. Of course, we need your name, address, and stuff like that. The first part is what was the value? And it could be in any one of these 3 categories. So, if it's a business concern, how much money did you make by the investment or the product? How much profit? Did you save a lot of costs? If you're a government or a scientific organization or a university, what kind of scientific discovery did you make? Did you discover something new? What's the value of it? And then we include a third category, value to society. Ending nuclear testing. Hey, that's pretty good stuff, as far as doing that. But even, on homeland security issues and that. So it can be any one of these 3 categories can be the return. And then the last part here, we do need to know just how much did you spend on your HPC system to solve that one problem. And that's basically all that's needed from the site to make a submission for it. The judgment process, we try to make it very streamlined, very transparent in that. So first the submissions have to come in, and IDC just determines, was a value stated that's understandable, and was the investment clear? And basically those are the only 2 things. There's some other stuff we track too, like what vendors' equipment and software, but even if those are left blank, that's not an issue to us. We just do a quick, do you comprehend the value? Was it clear enough? Then the second assessment is made by the User Forum Steering Committee as far as, which ones are really the high value ones and, are very clear. And if we have a case where the value is not clear, that we don't have the technical expertise, then we have a set of domain experts we go to make that evaluation. So what we'd like to do is announce the winners, and we're very impressed. Beijing Genomics Institute, this is the second time they've won one, and they're just doing some very major and impressive things. We've done a press release that describes each of these in detail, and I want to leave enough time for Q&A. But GE Global Research also, Richard Arthur. DOD, HPC MP Create Office, John West. The DOD has done some tremendous evaluations of the investments they've made in it's just tremendous. Aon Securities is another one, so it's the first time we've had somebody in this industry sector, which is great. The success area describes of the categories I mentioned which ones they did. Also at the Mary Bird Perkins Cancer Research Institute. So, another very interesting one from another one. In this case here, the categories as far as the return on investment.
And they're Louisiana State.
Sorry, Louisiana State there. So these are the 5 winners. We'd like to congratulate all of them. You do get a very nice trophy. It's a glass trophy like this, and we have all the sponsors of the award program listed on the trophy itself. And we'd like to invite everyone here to make submissions, or if you're a vendor, have some of your users make submissions too on it. And it's very simple. You can just go to the Innovation Award portion of the website. And then in summary, what we like to just summarize with 2 charts is why is HPC projected to grow so much? You've seen very similar bullets before from us, but it truly is becoming a stronger and stronger competitive weapon, whether you're an industry or a government organization and so on. And governments are recognizing that HPC leadership really is crucial. From the big economic recession and that, most governments that we work with have come to the conclusion that innovation is required to be successful in the future, and that HPC is a major tool for innovation. And so really they're developing national programs. I think right now, as far as, well, if I count the EU as one country, I think we're working with 9 different countries right now as far as trying to figure out how to use HPC better for that. The third one is there's some very critical problems out there that need to be solved in the world, and they require a lot more power than we have today. And I think that's the reason exascale is so enticing to many people. And then the fourth one is HPC just continues to be a much more cost-effective solution than doing it in a lab and actually doing live research. But there's still the major customer pain points that we probably have mentioned 4 or 5 times here. Really, the software is the #1 roadblock, but clustered systems becoming hybrid, you use GPUs, you use mic, how you put them together just continue to be more complex and more difficult for organizations to deal with. And our recommendations to vendors is look at this chart right here and prioritize your investments here, because these are the problems that need to be solved, and I think you'll be rewarded for solving those. And then the last one is one you've heard from us just more recently, is the return on investment is becoming a larger requirement, especially as these systems scale and cost. When you start talking about making a $100 million investment just for the hardware, you're talking $400 million perhaps then for the building staff and everything else. We do believe that in the near future, meaning next 2 to 4 years, we'll see more than $1 billion supercomputer. And we're tracking those very closely. RECON's half the way there already. And here are the research areas. In the interest of time, I'll just leave that there and just ask if there's any questions that people have. Steve, you want to hand him the mic? Might be good.
Sure.
Yeah.
Wait for it.
Hi, Joshua Mora from AMD. The question I'd like to ask is, have you started doing already an analysis of the embracement of accelerators? For instance, there is research institutions that have dedicated teams to do computer science on new architectures, right?
Right.
And they are studying programming languages and things like this, and the hardware vendors are pushing these computer scientists to play with the technology, change algorithms, and so on. Could you do an analysis, or have you done already an analysis of the kind of level of embracement of those technologies?
Right. So in the interest of time, we had to summarize a lot of things here, but we actually do track and forecast the use of all the different types of accelerators. And when I mentioned that we're going to all the major centers now for doing face-to-face surveys, our surveys are about 3 hours long, and almost an hour of that is all around using accelerators or new types of technologies, FPGAs. I didn't cover this in detail here also, but the quarterly data tracking that I mentioned of tracking servers, This quarter, we've just added GPUs to that structure. So we're actually going to track on a quarterly basis how many GPUs are in each vendor's models. So we've created the data structure, and we just started to populate it this quarter. So at the end of this year, we'll have our first full year tracking, what I call a census level of all the GPU uses. We've done about 12 studies already, so we have a fair amount of background numbers on that. So if you're interested in them, just let us know, and we can tell you. We have switched our categories around some, because if you remember back with Roadrunner, there was cell technology, and cell looked like it was going to be a whole new category, and that dead ended. And then you had ClearSpeed with FPGAs. FPGAs are actually doing pretty well from a small number, but the whole action right now is in GPUs. So we've done quite a bit of studies, and we'd be glad to send that to you.
Yes, good morning. Walid Kahtani, Saudi Aramco Oil Company. Two requests and one question. The site where the reports are, you flipped right too fast before I got it, and the email to get the slides. Can you post them on the screen if that's possible? Thank you.
Right, so if you send the email, this is actually my email also, the HPC at IDC. If you send an email to that, I'll send you all the slides also. If there's individual reports you want, we only post a few of the reports on the public websites, but if you send us an email directly, we generally will send you the report.
Right, my question. You said the need for tiger teams, but you also said there's shortage of human resource.
Right.
Sounds like the egg and the chicken here. I don't see how you're going to do it.
Right, so what we did on that, when I mentioned we had to figure out a whole mechanism for the recommendations that would work, because of the recession, a number of the vendors have done some substantial layoffs right now, and right now there are some excess people in the market, primarily more on the domain expert side, but these tiger teams, their primary job is to do the scaling of the centers of excellence. So they have to understand HPC, and when I mentioned a parallel programmer there, these are not the top-notch, in-depth one. The top-notch ones are in the centers of excellence. The one thing I should have mentioned on the Tiger team is the rough number we're talking about is we think Europe needs about 100 of these teams. So we're talking about 200 individuals that are required for that part. And we think between, and then the third source, we also think it's a very good internship program for graduate students. Because they get to go around and visit all these sites, and the knowledge they learn from that is tremendous. So we actually put together a mechanism where I think we can find enough people. Again, these are not the tier A parallel programmers, because that's not what they're doing in this job.
Earl, you should also mention that the plan is not to have all of those people in place day one, but to build up over a period of a couple of years.
Right.
I had a question. Is this on? Oh, yeah, okay. So my question is about big data. And I find that I see it as a misnomer that it's not really big data that you're dealing with. It may be big, but it's really unwieldy data. And my question to you is, in all of your studies, are you focusing on the size of the data that's important, or the complexity and the unstructuredness of the data that's important?
We're focusing, like some other folks, on the 4 V's and so forth. The data has to be time critical. It has to be high in volume. It has to have some real value, and so forth. So there are a number of factors that all have to play in it for it to count as big data for us.
Right. And maybe I can add, we use the term big data just to have a name for the whole research area. As Steve was mentioning, we're looking at all the different categories in detail. And we didn't have time to give you our definitions. We felt that if we spent our time on definitions, it would get a little bit too long.
And the one other thing I'd add is, as I said before, we're really being driven in this. We're allowing ourselves to be driven hard by what's actually taking place out there in the market.
Right. It's like saying, well, HPC is big compute, we're done. We don't need to talk about verticals.
Right, exactly. And the other thing that Steve mentioned is the numbers that Steve showed is taking the current HPC market and what portion of that's big data. But also Steve mentioned that the gray area of business analytics and everything else looks like that's starting to turn into HPC. So a year from now, you may see us saying, well, here's the old HPC market, and here's this whole new chunk being added onto the side. But we haven't done enough research. We don't understand that yet.
One of the things that will be interesting is all of the border wars that will happen as inside of organizations as their commercial and the HPC parts of the organizations realize that they really ought to be working together.
Okay.
Yeah, so Wolfgang Gensch. And I have to ask that, obviously. So back to your list of lack of key talent, HPC key talent, one contribution to that could be definitely HPC Cloud, where you combine talent to provide this HPC expertise to the world. I mean, to SMEs and to other people who cannot afford even buying or hiring their own HPC experts. So they can get it. And by the way, I mean, HPC cloud is almost not the right word. So it is HPC as a service,
right,
which includes HPC expertise then.
Right, and we think that's definitely a path. We also think that right now the cloud use of the use by HPC sites of the cloud is very small right now. We do think that there's some tipping points where a lot of pent-up demand in HPC centers could be moved to the cloud in the future. So if some things change, we're watching it very closely because we think the clouds could become very large and very dominant. But not replacing data centers. It's to do more HPC work to help the growth part. Now, we think what you propose is exactly the model that we'll migrate to. But right now, the SMEs would have no ability to figure out where the cloud is, what to do with it. So we still need that face-to-face starting point. And that's why we mentioned those tiger teams. Because one of the avenues of the tiger team might just say, oh, for what you're doing right now, you need to use this cloud service here. They set that up, they walk out the door, and then they're happy as can be.
I think we're at 9 o'clock.
Ah, okay. Well, thank everyone for joining us. We appreciate it and enjoy the show, and it should be pretty exciting.